Good afternoon, Akonde. Akonde, can you hear me? If you can hear me, please unmute.
Yes, I can hear you. Good afternoon.
All right, good afternoon. Please enable your video.
Yeah, I'm turning it on now. Can you see me? Okay, great.
Yes. All right. So, good afternoon, Akonde. Welcome to your interview session with us at 54P for the role of a senior DevOps engineer. Um, my name is Abu Razak, and I work here as the lead people and culture. And on this call, I have CTO, Mr. Ayobami. And I want you to tell us about yourself, Akande. Tell us about yourself and why you are a good fit for this role. Thank you.
All right. Thank you, Razak. Um, hello, Ayobami. It's nice to have you on here. I believe I've spoken to Razak before, so yeah. I'm a DevOps engineer, and I've been in this space for uh, more than 5 years now. I started as a software developer um, before I went for my master's in Cyprus, and I continued as a software developer, a PHP developer, working on bank projects. And after that one, I moved to South Africa and I started working with ABM Industries, and I was a Linux administrator there. So basically, what I was doing is installing softwares, servers, um, putting setting up of something we called virtual internet protocol, which is VIP, and putting it in front of a GLSB, which is a global load balancer. Then then we were working also with machines with Ansibles and installing, setting up of cron jobs, upgrading servers, right? So it was lots of servers then, right? So we had to learn how to automate those ones, and so it was basically on prem. It was basically on prem, right? But I've started to understand the basics of how cloud works, like S3 and all that. Then from there, I moved to Bitro Business Technologies, and I was supposed to. So this is a data company, and the project we were working on was also a data project. So we're dealing with huge servers like Penthouse servers, managed Kafka, MSK on AWS. I was basically working with on the SRE side, Grafana, Xstack, using Logstash to onboard logs to Kibana. Then what else? Cloud Foundry. Yes, they were using Cloud Foundry. So that was the first one before the Kubernetes boom and all that. And there was little. It was bash scripting as well then. A little Ansible, I think. Then lots of GitHub, um, getting logs from different applications, right? So there was no GitHub action. So we're using Jenkins too for CI/CD then. So he exposed me to what Jenkins can do. So fast forward to payday. So I was the only payday is was because they have been acquired by a company called Changera. So I was the sole AWS DevOps engineer then. I was in fact in charge of managing the whole infra using CloudFormation. So I migrated their whole stack from what's the name of this? It always keep my mind. It's not Linode, but similar to Linode to AWS, saving them $3,000 monthly because they were working and their database was in Mongo Atlas, and the price in 1 month was just too much, and I actually had to help them to migrate it to DigitalOcean, which was way cheaper. Uh, in fact, was way cheaper. And then we migrated from um, that particular cloud to AWS. And instead of using EC2s, in fact, we were using Fargate because it was only two um, microservices that they were using. And they were using, I think, 10 instances for it. So we minimized that to about three, and we use auto scaling for most of the things. So it was it really reduced their burn rate. And from there, so I worked briefly while I was with Payday. I worked briefly because sometimes Lemfi people we work for them as contract basis. The CEO and Lemfi has called their, so I worked briefly with Lemfi before leaving for there, before leaving there to work at AppMicro uh, as a DevOps engineer. And over there, we're working basically with Kubernetes in a Kubernetes setup, and with Elms chart, setting up of their SRE stacks, their applications, and all that. Then from there, we moved again from Kubernetes because there was no point for it to EC2 in AWS. So then, now fast forward, I work at Spiro Mobility now. It's an electric vehicle company, and we have a robust application. We are in Kenya, Uganda, we are in Nigeria, we are in Egypt, and all of that. So I think about 9 countries. And so we build electric bikes. So it's a whole lot of infra on AWS, from working with EC2 to Fargate to Beanstalk to RDS to S3 bucket to Route 53 um, to um, name systems and all of that. So it's a lot. It's a huge. So definitely, I'm confident that I'm the right person for this job. So that's to summarize that, because it's a lot of this thing. There are some that I've not even mentioned. Terraform, Ansible, and all of that. Yeah.
Okay. All right. Thank you for the brief. Where do you currently stay, Akondi?
Presently, now I stay in Ibadan, but I come to Lagos. Like by the end of the month again, I'll be in Lagos. But presently, I'm in Ibadan. Yeah.
Okay. All right. Thank you. That it for me. I'll hand you over to the panelist Ayobami for more questions. Thank you.
All right. Good afternoon. Sorry, what's your first name?
Adedayo.
Adidayo. Okay, okay. Good afternoon, Adidayo. Yeah, how are you doing today?
A little
You,
bit cranky, but I'm good.
okay. You stay in Ibadan.
Yes, presently, yeah.
Where in Ibadan?
Ashibodija.
Ah, Ashi. Yeah. Okay. I'm a native of Ibadan, actually.
Oh, that's good. Where do you stay in Ibadan?
I don't, well, I don't currently stay in Ibadan. I stay in Lagos, but I was born in Ibadan and schooled in Ibadan. So, um, my ancestral area is not so far from Ashi. I know Ashi very well. Mm. You know Glory Tabernacle?
Yeah, I know Glory Tabernacle, yes.
So, yeah, so all those areas to Akimbola. Do you know Akimbola?
Yes, I know Akimbola.
So Akimbola is my great great grandfather.
Oh, wow. Big name.
Yeah, yeah. That's that area is that's my ancestral, and that's where my father's house is.
Oh, okay. Okay.
Anyways, so you're welcome.
Thank you.
Okay. So you currently work remotely?
Yes. Yes.
No, okay, okay, no problem. So let's get into it. So it may be fairly long, a long session, right? But I mean, just concise and concise answers. Okay. So, are you currently certified AWS?
Uh,
Not that anyway. I'm just asking. Don't mind me. It's
yeah.
the skill that we need.
So the
Uh,
highest I got was practitioner. I have. There's no need for it, right?
there's
I
no
have
need. It's the
those.
knowledge that matters actually,
Yeah,
unless you just show off and all that. It's the knowledge and the skills.
yeah,
That's fine.
yeah. And I
Oh,
work
oh, oh,
for. I've always been working for product-based companies, so we don't need it. So yeah,
oh, okay, okay, okay. That's fine. Okay, so let us get into it. So, what's the difference between vertical scaling and horizontal scaling?
okay, that's a good question. So say for instance, right? I have. I'll just say I have an EC2 instance. Let me just use an EC2 for this example, and
Mm,
we are using like 2 gig RAM, let's say like 8 gig memory and all that, and we don't actually want to do anything like auto scaling or double it or triple it or something. Can I just
mm,
change the RAM to 4 gig, 5 gig, and change the this thing as well, the CPU. So that's vertical scaling. We are just changing the RAM and all those ones. But horizontal scaling is just auto scaling, right? I have one EC2. I put it in auto scaling. If there's high traffic, I want you to increase the instance to 2, or increase it to 3, or 4, or whatever you want to. You can do
mm.
it. So that's just basically vertical increase
Oh,
in sizes and
yeah. So, thank you so much. So, I like the fact that you applied AWS as the example. Okay. All right. So the next question is, if I have, okay, is your attention required there?
it's my son that just came. He's like, go outside.
No,
Yeah,
no,
I'm
it's fine.
listening.
You can. I mean, you can attend
I'm
to.
sorry. Please, let's continue. Let's continue.
No,
He's
no,
going
no, no, no,
outside.
no. Not. Why are you sorry? No, attend to him. It's fine. Oh.
Okay.
Attend to him. It's fine. It's fine. No,
All right. Sorry about that. He has gone out. All right.
no, it's fine. It's fine. Okay, yeah. So before I go to the next question, right? I currently have I have an instance minimum of one set to auto scaling, and it's supposed to auto scale to 10, right? But there was a day it auto scaled to 3, and then the RAM, the memory on the three instances were maxed out. It was supposed to continue to auto scale. So what could have happened
That's a good question. So it was supposed to auto scale
to
and did
10?
not auto scale. So the memory was maxed out.
The memory of the three, it got to 3 and the memory maxed out.
So
And
it
we were down for 3 hours or 4 hours that day
all right, great.
before we realized.
All right. So the first thing about it is when the whole thing was in auto scaling and it was the memory was maxed out. The
Mm,
first thing would have been all right to check the metrics first. But the thing about it is that metrics for EC2 doesn't come there. You can't see the memory, especially. So there's something we use in Ansible to bring out those metrics, so you'll be able to see. It's only CPU that you see. So if that metrics is there, of course you'll be able to see what's going on. That's one. Two, then you can always do something called instance refresh. So in your auto scaling, right? First go to the auto scaling. You see something called instance refresh. If you do instance refresh, it will come down. Of course, the memory will come back up again, but your system will be able to come up. Then the reason why the thing did not auto scale anymore is because Probably you only set for memory auto scaling. You didn't set that if CPU was down. You have to if CPU was up. Probably if memory was up. Probably you only set for CPU. You did not set for memory. So if you not set for
Okay.
memory, it's not going to pick it automatically, right? So it's not going to you may only see that okay, oh, fine, it's the CPU that is going up, and it needs to increase according to CPU and increase to 3, and the CPU is now stable, but the memory is going up and up. So definitely it will not scale up again for that one. That one is another scenario. Yeah.
Okay.
So
Okay.
yeah. So that's what I feel would cause that. Yes.
Okay, valid, valid. All right, thank you for that. So my next question is blue-green deployment.
Okay.
Have you done it before?
Yes, very well.
Production.
Yes, very, very well.
Oh, can you talk us through it?
So I will just talk about the last project I did for Blue Green, and it was basically a Fargate application, and it's backend, and it's fairly easy. So Blue Green is just like, okay, all right, I want to deploy my application, right? But I want to have like a test target group, and I want that target group to give me a go ahead that fine, this thing is good to go. Only when it's good to go should you switch to green deployment, right? So green deployment means switch to another new deployment. So I have let me say I have a deployment of version 1, right? I want to deploy version 2. So once I deploy version 2, it will first go to a test target group. There's a listener which will be, let's say the listener is listening on 8080, which will first pick the application and make sure the application starts before it now switch to the green, and vice versa if I want to deploy another application. So what do I mean by this? It's fairly simple. I have I have, let's say I have an EC2, or let me still use my ACS. I have my ACS server, and I have a code deploy that I want to use code deploy for the blue green, and I've already chosen good code deploy, and then
Mhm.
you have a test server. You call it. You have a test this thing, a test target group. You call it blue TG, and then you have a green. That green, right, is exactly the prod server. Both of them will have that health check. They will have the same maybe slash health or something, right? After you've done that, right, you have a code deploy application. Then you have a code deploy group, which will be monitoring the old stuff, right? So then you have a listener, which is attached to your load balancer. The listener, the first listener will be listening to blue TG. Let's say the first listener is 8080, will be listening to blue TG. And the second listener, which is, let's say, is 443, you attach a this thing to a certificate manager to have an HTTPS. It's listening to the production. So anytime I want to deploy, the blue will be the first one to collect my connection and to say, okay, the application is start. If the application does not start or there's an error, it will not switch to green. It will only stay to blue, right? There will be no change.
Mm.
But if it
Okay.
starts and the edge check is good, it switch to green. That's the only way. Then the green will now be deployed
Okay.
successfully. Then you see the new version. So
Oh,
that's basically it.
okay. That's fine. That's fine. That's fine. Okay. So this is my next question, right? Two questions came to my mind, but this is more important to me. I have in my environment, I have my environment today, right? But there are some merchants, right, that we classify as super merchants.
Okay.
By the way, you know what we do?
Of course, payment is payment.
Okay, okay,
Yes.
okay. So there are some merchants that I classify as super merchants. Merchants can do at least 10,000 transactions a day. Worst case scenario, Worst case scenario, 10,000 transactions a day. So those merchants, right? What I want to do, what I want to do with them is when their request hits my environment, I want to have a dedicated um what do you guys call it? Don't mind me, I'm an engineer. I want to have a dedicated what's the
Is
word
it
now?
endpoint? Is it load balancer? Is it API?
Um Load balancer, yes, but what was the term that you guys use for that? Load balancer, API gateway, instances. What was the generic word you used to for all those things?
Maybe application load balancer or something.
Okay, but this is it. For that super merchant, I want their own traffic to pass to go through a different API gateway, a different load balancer. I want a separate environment for them.
Okay.
Do you understand?
Mm-hmm.
So let's say I have four services. I have transfer service, I have collection service,
Mm-hmm.
I have virtual account service, five services.
Mm-hmm.
I want to create a mini environment, a different environment, all my services, a copy of all my services for those guys. They are like two or three. Do you understand what I'm trying to say?
I'm
So the
listening to you.
moment when their request comes, their request will go to their own environment. Let's say super merchant A. Super merchant A's request will go to their own environment and it will be eating their own, you know, their own instances. Do you get? Super merchant E, its own request will go to his own, you understand? But
Mm-hmm.
meanwhile, we have a central database.
Mm-hmm.
Everything that happens in those will still, you set database is one.
Mm-hmm.
So, can you okay, very quickly, do you understand what I mean? And
Yeah, yeah, I understand you. So, for instance, you have different services. Let's say there are five microservices, right?
sorry,
Uh,
the word I was trying to look for, I just logged into my into my AWS, and the word I was looking for is cluster.
Cluster.
So we have a generic cluster for everyone. I now want to have cluster one for super merchant one, cluster two for super merchant two. Do you get?
Is it what kind of is it Kubernetes that you are talking about or what? I don't
Um,
understand the cluster that you're talking about. Or is it EC2
okay,
clusters?
EC2 clusters, not Kubernetes.
All right, EC2 clusters. All right. So I get you. I understand you. So the I'll I'll explain two ways, right? So
Mhm.
yeah, the first thing is we can do something, right? And the first thing we can do is we can have a load balancer in front of all the services. We are going to use a single load balancer. So we are going to configure something called a path-based routing so that
Mhm.
by the time there's a connection from your from wherever it's coming from merchant, let's say it's coming from merchant A or whatever is right, the path based routing, right, we say okay fine, this is a listener 443 https, it will route it to slash merchant A, then slash merchant. So that merchant A will have an endpoint that will have their own specific endpoint. Maybe merchant A dot kidney at the address.com. Then merchant B will have their own too. Then the clusters will have their own too. That way we're able to separate different places where they are going to, right? Are going to be. So that's one. Second thing, we can use API gateway for this, right? We can just separate those API. We can use API first, then we'll separate the routing using the API slash this thing. We would have configured it from our application slash merchant A goes to merchant A slash merchant B goes to merchant B. Then we'll put load
Mhm.
balancer behind it. Once we put load balancer behind it, it will be able to go to that cluster, this cluster, because all those services we have different names, right? So
So
with
say
that,
that again.
all those services will have different names on their EC2 machines.
Yes, yes,
So and they will be in their own auto scaling, which is their own cluster.
yes.
So yeah, of course. So the load balancer sitting behind, we auto scale it. So like I said, we can use a path-based routing, which will point to different routes, and those routes will point to different endpoints of those services. Or we
Mm.
can have API gateway that we can do and will point to different parts, then
Oh,
have a load balancer in between it. So that will work.
okay. All right. That's good. So very quickly, the second question, right? I told you the other time that my one of my key services went down for 4 hours, and I was not aware. Right?
Yep.
I want to know every time a
It
service
goes
is
down.
down. Yeah.
All right. So the beauty of it is to be able to see it into the system, right? And one of the powerful things are logs and metrics, right? So for AWS, you can use CloudWatch. But as my experience grew, uh, CloudWatch for startups, from I've worked with startups very well, is not a very good idea because of burn rate, right? Takes in consumes lots of money. So setting up of alerts is very intriguing. When it comes to log errors, like okay, fine, if you are trying to hit a particular API more than 5 times and it's showing like something like 400, 401 errors, we want to log that. If that is more than five, all those things can cause, that means our backend is not working, our business logic. Maybe the customers are getting too much for, and if it is 500 errors, that means something is wrong with our servers, which is from DevOps side, right? We want to log all those ones. If it's more than five, we want to consequently check. So all those ones, we set the alerts for it. Every time it's sending me alerts. Then we want to set alert for memory, for this thing, for CPU and memory. If it's high, and if it's way too high, it should tell us. And if it's down, right, it should tell us. Sell email. Then at the same time, we can attach it to whatever CI/CD we are using. So, for instance, we have in our Jenkins, we have what do we call this thing? No, Jesus, webhook. So we have webhook that we can configure from our Grafana. We can even still do it in CloudWatch. That will always send us information, even so that when we are chatting on Teams, on Slack, or wherever, we get to know if something goes wrong. That's another one. So CPU memory. Then again,
Okay.
yeah. So then again, database as well, right? You want to know when your connections are too high, because apart from EC2, if the connections going to the database are way too high, definitely your this thing will go down. Your application will go down, right? You want to set alert for those ones too. So you want to set as much as possible alerts, so much that you get alert almost every time when any small thing happens, right? Those are one of, if in fact before it happens too, you get it, so that you say check this, what is wrong with this. If the staging goes down, you're able to say okay, fine, what caused the staging to go down. Before, maybe it's a late deployment, maybe some kind of code happened, and now the code has spiked so much errors, right? That one is there. Then you can, for application logs, you can turn on access logs. It's expensive
Mm.
too, but it works. Or inside your this thing, your application, you can add something like traces, like open telemetry, Node.js and all those things. They have it, so you can track your
Mm.
API calls and see where they are all going, right? To see, okay, fine, how fast is this going? All right, is there some bugs in your code? And again, you can have in your, because like Grafana open source can have error info one. So you see one errors, you see all those things. So all those ones you'll be able to see what is going on. And
Mm.
Mr.
Okay.
Ayobami, you get it.
Okay. Can you?
No, so I'm saying like it's not you like as a DevOps engineer, so you just get all those things done.
Okay. 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 That's fine. That's fine. Thank you for data backup and replication. right?
Yeah.
For any reason, I don't want to lose any data. For any reason. As a DevOps engineer, what will you do?
So in terms of data, right? The critical data is logs, our database, our backup. Those two are so very important. Let me see other ones too. Except maybe you want to scrape data from what these things the developers are doing, then you can start using data engineering powered by people. But for those ones, logs and data backup, so we can set cron for those ones. So we can always get something like a dump of your database like every 7 days and save it in S3, right? And after saving it as in S3, because dump consumes lots of space on EBS,
I did
like
that. It's 7 days. Is that not too long a time?
for logs, that's not too long for
No,
logs. You mean
yeah,
for
but
database?
I agree for logs, but for database, is that not too long?
Uh,
7.
I I wouldn't say it's too long because of course you have your snapshot of your database at every point in time in S3. So if you are running SQL dump every 2 or 3 days of your database, it's going to be consuming lots of your CPU memory. It's just going to be going up and down of whatever EC2 you are using to get those dumps, right?
Hmm.
So you can always get snapshots of database and save that in S3. That one can occur like 2 3 days according to what you want on AWS instead of cron using cron all the time, right? So that's another way I think we can do that. And
Oh,
yes,
okay.
and for stuffs like EC2 and for stuffs like EC2 backups like AMI, you can always take golden AMIs of your EC2 at every point
Hmm.
in time, maybe like every 3 days. And you set the life cycle management that okay, fine. Oh, once these AMIs are up to 10, I don't want more AMIs to be saved again. Delete the old ones, keep the new ones, right? And the golden AMIs are always going to be the one that is running right now, right? So that's another one. Then in case of containers, another backup and all that, you can always have like 10 in your repos and all that. So uh
Oh, oh,
yeah.
okay. All right. Thank you so much. So, security of resources, right?
Right. Yeah.
Can you can you talk us through very quickly because of our time? Can you talk us through your strategies to ensure that our environment, our database, so is secured at all times?
All right. So I'll start from database. So the first thing for a database is always to always deploy a database in private subnets. Always. And then you want to have something like a NAT instance to always access it. So what the NAT instance does is stand as like something like a bastion host. So you have um your, for instance, your staging, your product or anything. I don't know what you are using, right? You deploy the NAT instance in public, the this thing in NAT in a private subnet. Then you use something called SSH tunneling to actually access those databases. Same with the developers, right? So what we do is the NAT instance that you are using to access that database, you collect the public keys of those developers. Public keys. You not give them the instance key. So the public key is what you upload inside the NAT instance, so that it will be like okay, where even if you're on another person's system, you cannot access it. It has to be the system that you are using, right? So that's one. Two, the security group that is coming only have to be from the NAT, and the NAT always have to allow, if you are using VPN, which I always say is very good. If you are using VPN, you just put the IP of the VPN in the NAT. So that way, any developer has to connect to the VPN first before connecting to the NAT, before going to the database. which is very secure. So, and if not, you can always say, where what is my IP? What is my IP? You give the DevOps guy your IP. I'll put it in the security group for that particular moment. You're able to access, right? And if it's from EC2 to this thing to the database, they'll both be in private subnet. You only have to allow that security group 5432 or 27017 or 3306. You have to allow it from the particular IP, which is the private IP of that instance. So you use IAM role to connect them together and they'll be able to work. So from that place, I think that's good enough. And you can always, in terms of access to developers, it's only advisable to give them read-only access. And if you are using PostgreSQL, you can do that. If you are using SQL, you can do that. If it's MongoDB, you can always give you read-only access, and that's you won't be able to read. So for
Oh,
database, I think I've covered some. Then for EC2 virtual machines and all that, it's always good to actually deploy in private subnet as well, except for stuff like DevOps things like SonarQube, Jenkins, um, uh, what else? Jenkins, like our Ansible machines and all those things. You can have them in public subnets. Nobody's trying to hack all those ones, and if they are trying to hack it, what would they get inside? So you can always put them there. Then the normal application instances should be in private subnet. Can access them through session manager. One. Then two, you can access them through SSH tunneling as well. And again, your security group will be configured. Then for people that want to using DDoS attack and all those things in your application, can always use fail to ban to get their IPs, block it through network access control. That one is there. You can even block them through security group. That one is there as well. So what else?
okay.
Um,
I think I'm fine actually. I'm fine. Okay, yeah. So final question from me, right? So we're a startup and we're growing every day, like every single day. So we have no doubt that we soon leave the league of startups in a few months. We have no doubt about that. However, um, one thing we need to do or we must do is to ensure that number one, our services are stable, right? Then number two, in this period, right, because we don't have a lot of money, cost optimization, particularly cloud, is very, very important. So, can you tell me your cost optimization mechanisms, or yeah, or are you the kind of DevOps engineer that cannot walk around the budget? There are some DevOps engineers that they will say, if it's cloud, we must spend money. It's a must, right? So, what kind of DevOps engineer are you? And then, what's your cost optimization strategy, basically?
all right, thank you, Mr. Ayobami, for that question. So the good thing is I've worked with three startups now, and even the spirit I'm working with now, we are still a startup. We are still a startup, right? Making electric bikes. So we care so much about cost. In fact, one of the things that can bring a startup down is cost. And I've seen that many times when people don't know how to actually do it. So I understand perfectly. So number one is before doing anything, right? It's always very good to go and check AWS calculator for whatever you want to spin up and take approval. That's one. That's the first thing. Well, right? We want to spin up an EC2 instance, blah blah blah. We want this, we want this, we want this. Developers come or whatever people comes and all that. And secondly, there are some certain instances that that are just good for certain workloads and are not expensive at all. I'll give you an example. So there are some instances called graviton instances, right? And they are for AWS. All your EC2s, some don't need x64 based. X64 are like the standard of EC2s and very reliable, so I understand people use it. But it's not all. If your bill in a month say is $100, I can guarantee you that if you are using those Graphene instances, whether for your RDS, whether for your Kubernetes cluster, whether for your EC2, or whatever you are using it for, I can guarantee you that your bill will be slashed by half, $50, without sacrificing reliability and performance. Of course, there are some things that you to want them to be able to perform very well according to scale, right? That's one. Then two is you want to set alerts of budgets. All right, how much do you want to spend? And you want to keep track of your cost savings. So there's something they call cost savings in AWS that you can purchase. Once you purchase it, it will still be saving you money. Like if you purchase it, it will be saving you money. And some of the things that you can't even see, it will save it for you, right? That's another thing. Then right, so you have list of uh your cost, so you always
So
compare them. Yeah.
Sorry. No, no, no. I mean, I'm soaked into what you're saying, right? So I just want to. You got me thinking, right? I think if I check my billing, right, I think the highest one every month, the highest is always the EC2, right?
Yes.
So that's always the highest every month, right? So and it's I think even over 50% and or close to 60%, if I'm right. So are you saying the RDS will is going to help us?
In fact, the architecture of the EC2s that you are using is going to help. Like I said,
Sorry,
that's
ECS.
ECS. Yes, of course, you can always use Graviton instances for ECS. Then again, for ECS, there's something that we do, right? For Docker containers or any containers, we have to know how much our application is actually consuming. So, for instance, you can check Docker stats for it and see what your application is consuming, and that's what you will use as a benchmark for your applications when you are spinning it up. So you are not going to say, okay, fine, or like for instance now, I'm not going to blindly say, all right, I'm just going to choose 2048 MB, which is 2 gig, and 4096, which is 4 gig for my memory, right? I'm just first going to ask the developers, all right, how much CPU and memory is it consuming? That's what I'm going to use. Then, like I said, there are just some instances that you can use that will not cause you to spend more, right? And then set your auto scaling. And sometimes you don't need to use blue green for some. You can just use what's the name of this one? This normal one that just change, that just switch. This thing is not blue green. What's this deployment strategy? If I remember, I will let you know. So you can use that. So yeah, ECS can be costly, but EC2s, if you are using lots of EC2s, can also be expensive. Don't forget that ECS runs on EC2 in the background,
Mm.
right? So the key is to know which instance to use, which instance not to use, which architecture to use, which architecture not to use, right? And then have some savings plan that you can buy. All those things will definitely help.
Oh, okay, okay,
Hello. Whoops. Lost the connection. Trying to connect. Okay. internet come back.
Can you hear me now?
Yes, yes, I can hear you. I can hear you.
So
Yes.
I said that the question I asked about the dedicated cluster for some merchants. Mm. So can, I want to see the architecture,
Okay. Can
right?
I
Is
draw
this
the
some?
architecture?
Yeah, yes.
Alright.
Not now, definitely.
Oh,
I
okay.
so can I share my number? So when can I have it? You can share with me on WhatsApp.
All right, all right. Yeah, I can text you on WhatsApp. Then you can properly we can go through the steps that you say you want to do. Then of course we can come up with the architecture. That one is not an issue at all.
Okay, so the steps is just the steps are these, right? So we have a general environment,
Mm-hmm.
right? So we want to create, can I say, a copy of that general environment, right? For, let's say, three merchants. I think the super merchants are no more than three. So we have our general environment. We have maybe copy one, copy two, copy three. So we have four environments, right?
Okay.
So all the traffic, okay, the traffic of super merchant one goes to copy one environment. The traffic of super merchant two goes to copy two. The traffic of super merchant three goes to copy three.
Okay.
The reason why, and then the traffic of any other merchant goes to the general environment,
Okay. Okay.
right? You
Yeah.
want to draw it now?
Yeah. I'm sharing my screen. So I just want to understand very well, right? We can just do
Yeah.
this. So
So so the do you understand? The reason why we are doing that is that to minimize, because these guys, right? They have a lot of traffic. We don't want a situation whereby our once one environment is down, everybody, all the merchants will. So if the general environment is down, my super merchants,
you don't
their
want it to
transactions
affect
are,
them.
it does yeah, their environment is still up. So the three of them, they are still processing transaction, right? So
Okay.
even if the environment of super merchant one is down, super merchant two is still processing, super merchant three is still processing. But now this is where I don't know, maybe it will be simple, but it may get tricky.
Okay.
When we do a deployment, the deployment must be replicated across all the four environments.
Okay.
Exactly. So if I do an update, so from the pipeline, it must update all the four environments. Of course, we have to implement blue green as well. Do you get now?
Yeah, I'm getting
So
you.
basically, that's just it. Sorry for the background noise.
Yeah, it's all right. It's all right. So what you are trying to achieve is right. Merchant eight. Let's say this is merchant eight coming to. I will just make it very simple. We have a particular server. Can I reduce this thing? Yes. We have a particular server for this merchant A, right? And then we'll have one server as well for this guy. So what you are saying now is you want all your merchants to have a cluster, to all your merchants, important merchants, to have one single cluster, while this general as well will have a single cluster.
Exactly.
Is that what, if I get you? So that means this guy merchant A, um, this merchant B as well, right? Let's just say merchant A B, they will come to this guy, then this one will come to this guy, and this one will have like let me make it big, is we have like, let's call it like an auto scaling or cluster or whatever we want to call it. Let me send this to back. So this will
I,
be
I,
like,
I, I I want it in such a way that merchant A will be separate from merchant B. So that if anything is wrong with merchant A, merchant B will still be processing.
Okay, I get
Do you
you.
get?
Yes.
Mhm.
Okay, so let's do it this way. So it will still be processing. Let's just do this and let's make this instead of you to come here. So you come to this cluster right here. So this guy will come here.
Exactly.
So this one will come to this place.
Correct.
Yes. All right. This one will come to this place. All right. So then this will be, let's say, another cluster. So it's money that it will chop. It is very possible. All right. So
Eh, so
so
I mean, because they have, they say that it's money that you use to find money,
yes, yes.
right? Uh-huh.
So what we can do right here is to have something here called a load balancer. It's just going to be one single load balancer,
Mm-hmm.
right? So let's call this an ALB. You don't have any application that is using TCP, right? Everything is
No, 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 we don't.
all right. So let's say, for instance, what we are going to do, what we can do is that we have to have a logic here that will have this thing. So we'll say this guy will have API of merchant A, and this guy right here
Mm-hmm.
we have a route of merchant B,
Mm-hmm.
right? This one will have a route of merchant B, or however you want to do it. Then this guy right here, we have all their microservice as well. We have their own this thing too. So it will this one will still be sharing their load balancer with them too. This guy will still be sharing. We are going to use one single load balancer, and this guy right here. Then this one as well. We have different servers, whatever it's I don't know what you call them, maybe invoicing and all that, right?
Mm-hmm.
What we will just do right here, what we can do right here is we can say general slash general. Let's just use this as channel slash general. What we just do right here is we'll have this cluster, we have merchant.a.com. This cluster we have merchantb.com, so that when you are sending message from merchant A slash this merchant, it will come to merchanta.com. This one will come to my. So now you're going to have different endpoints in your code that will be sending to different this. I don't know if I make sense. I'm still thinking about it very well, but I don't know if I make sense. So we are
Mm-hmm.
just going to use different parts to send to different endpoints, to different
Yeah,
clusters.
I guess it. So I mean, we can talk more on this. So I just want to see if the variation. I mean, if it does not increase our cost by more than, I hope it won't double our. If it doesn't double our cost, if it's less than double, I'm fine with it.
All right, all right,
Right? So
yeah.
let's say our average cost today is around $550 a month. So if it doesn't add more than say 250 to it, I'm fine with it.
Okay.
So,
All right.
but we can talk more about it. So it's fine. Thank you so much.
You're welcome.
Ransa, that's it.
All right. All right. Thank you. Thank you. So, uh,
All right. Thank you so very much, Akonde and Ayobami. It has been engaging, really. So, we've come to the end of your interview session with us, Akonde. And I just wanted to ask, do you have any questions for us?
mm, the question I'll have, I already know some that which is good, AWS, which is my core. And then, what programming languages are we using? What's our stack? Sorry, I'm already saying. What's the stack?
So it's fine. So basically, it's Java Spring Boot. We use Amazon SQS,
Okay.
right? For yeah, for our synchronous messaging. We use Redis for the packet chain. What else? We use Postgres, right? We use Twingate VPN.
Oh, great.
What else do we use? What else? Yeah, so basically that's it. So as we progress, right, we may do some .NET, right? We may there may be a need to do some .NET, right? Because if we have the need, if we have the need for it, because I have some senior .NET resources, engineers, right? So if we have the need, right, and they are very good, we may need to do some .NET, but for now, not in the immediate future. But basically, that's what else? What else am I missing? I think generally that's what we do. And I think our front end, what was that thing again? Or so our front end basically is React. Our
React.
front end is React. So basically, that's all we do.
All right. All right. That's all. Well, my questions. But thank you very
All
much
right.
for the answer.
Thank
All right.
you.
All right. Thank you. Thank you. So we've come to the end of your session, and I would say you have a wonderful